hopefully it'll pick up the video part too. This thing starts at about 45 minutes. Anyway, so network address translation. So somebody tell me, what is the big idea, the overarching idea related to network address translation? When you hear that term, what's it communicating? Nate?
You can't use your local IP on the worldwide internet, so it has to translate it to a worldwide IP. Or you can translate between local networks.
Yes. So if you think about throwing something like a router in the middle, on one side you have your local address, and then on the other side you could have your public IP address. Now, the direct definition of NAT is a one-to-one translation. So this word implies that there's a world in which there's one private IP address over here and there's one public address over there. Unfortunately, that's not terribly useful. And so we call it port address translation when we put a whole bunch of different computers over on one side of here in the local area network. And then we use port numbers to differentiate who made a request as it goes out across the one IP address on the other side. Okay, so here's your challenge. I don't know if you have a drawing tablet or a piece of paper. I would like you to diagram sending something to and from a website using everything you know from this class right now. So, like I said in the first bullet point, part of this relates to what are the devices that are involved, and then the second part is, what's the role of addressing at each step in there. So the devices and the addresses. Try to replicate and explain how something goes from a PC out to a server and back. Good luck. This is a good warm-up activity for something you'll be asked to do on exams. So, just saying, might as well study now.
So here's my iPhone. Okay. Why don't we switch to a router? So we got so far. Then you go to other options. And that is hooked. Sometimes the routers and switches are the same, right? Yeah.
can see that many enterprising individuals have just pulled up the image in Slack. So we might as well just carry on. So actually, I'm choosing to emphasize right now just a subset of that question that emphasizes the role of ports in communication. So walking through this, if I'm a computer over here, and I'll be computer A, and my IP address is, I'll make up a new address, 10.0.0.2. All right, now it's different than the diagram was. All right, so, and I've got some website out here. Maybe it'll be BYU or something, and I'm talking to it from home. So I'll do some, I don't know what the addresses are, but like 110.0.0.2. So if I'm going to send information back and forth to there, one of the things going to happen is I'm going to go through a router. I guess I should do a different picture of a router with the arrows, but on the inside of this router, it's going to have some IP address, some private IP address, 10.0.0.1. And on the outside of that router, I'm going to have some public address, and maybe I'll make it, I don't know, 99.99.99.99. Why not? All right, make it consistent. So if I'm going to send a request out from here to get a web page that's over there, my source destination, my source IP address is what? 10.0.0.2. What's my destination IP address? 110. Yeah, it's the 110. 110.0.0.2. All right, and then it hits the router, and then it's going to be carried on. So for this request that's going over here, what is the destination address? Where's it going to? 110.0.0.2. What's the source address? Nope, yeah, so this is publicly routable. That's not. So the source, so what happens is the router's restamping my IP packet. So there was one IP packet here, the router restamps it. So now the source is 99.99.99.99. And it gets, in an ideal world, it gets here. But if it did get here in that state, this particular server would be like, what are you asking for? It has no idea because I left something out, which is, like, which application is this packet destined for? Yeah, I need a packet, or I need a port. So if I'm looking for a web page, I need to have a destination. So I need a destination port. And what's the destination port going to be for a web page? It's going to be 80. Okay. And then here's the important part. What is the source port that we're sending from? We'll just call it random. We'll just call it random port number 1. How did this get generated? My operating system / my browser just made it up. It makes up some port. And it might be some number like 33,210, for example, if we want to make it real. All right, so then it hits this router, and then the router does something kind of nice to make us anonymous. Not only does it restamp my private IP address, it also restamps my port. So what's the destination port going to be? 80. It's still going to be 80, so that's going to get carried on. But what's the source port going to be starting from here? 4. It's not going to be this anymore. What's it going to be? It's going to be random port number 2. So maybe it comes out to 37,001. All right, so we go over to this website. This website receives this request. It gets all that information. All right, now it's going to send some information back. What is the source? What's the source IP address at this point? It's the 110. what is the source port as it's coming back? Where's it coming from? It's coming from port 80. All right, what's the destination IP? It's the one with all the 9s. 99.99.99.99. And then what is the destination port going to be? It's going to be random port 2, so the 37,001. So random port 2. It gets all, so now this gets all the way over to here, and we're going to get, the router is going to restamp that packet. What is the destination IP address? What's the destination IP address?
10.0.0.2.
Yeah, destination IP is 10.0.0.2. The source IP is what?
10.0.0.1.
It's no. Where does where's the packet coming from? Pardon? Yeah, it's coming from this 110 out here. So 110.0.0.2. What is the source port? What's the source port? It's 80. And what's the destination port as it goes from here to here? What's the destination port? It's random 1. Okay. Maybe the use of so many 10s wasn't awesome there. 10s and 110s. Yes, Eli.
So the router restamps.
Yes.
Going from private to public, but then going from public to private, it doesn't restamp it.
So it restamped it
Yeah.
on the way out.
But on the way in, it doesn't.
And then on the way back, it had this information right here. And it's going to restamp so it's going to get it with the random port 2. It's going to restamp it back to random port 1. And it's going to restamp the destination IP address to be the internal private IP address.
But the source IP address is 110 still, right?
Yes. Mm-hmm.
Okay.
So the stuff that's getting restamped is the original source local IP address as well as the
Okay.
random port number 1. So as this request goes out, this router is going to keep track of some connection between this port number and this port number, which it just made up. And so when it sees that number again, it's going to look it up and say, oh, I know who that is, and send it along. Yeah.
So then is the picture post on Slack incorrect? Because from the router back to the A, it shows the port and the IP address from the router, not from the destination.
It looks pretty incorrect.
It looks.
From what you did, this like diagram on Slack is really wrong.
That's all right. Let's actually want to get it wrong.
I have not looked at their diagram in detail. I just assumed that it was right. You're gonna get wrong answers in addition to that. So, okay. Yeah, we should. So if somebody would like to volunteer to redraw the diagram and post it, and nicely tell section 1 how how it is. And then a little tagline from the Mandalorian because I said it, or whatever that guy's. This is the way, but then there's. I have spoken. Yes, that one. Just by memory. We just know that traditionally web servers are on port 80. So that's just one way to represent it. That and 443, which is the secure URL. Okay, so we can certainly come back and review that. You can take a picture real quick if you want. I don't care. We'll be back to that. We can review it again on Monday. Based on how far we kind of sort of got, I think that the web stuff that I was planning on doing today, I'm going to push that back till after the exam. I might even push back the homework assignment that I just assigned. I'm super excited about that homework assignment. It's awesome. I mean, table making's fun, but spinning up web servers and stuff, I like that even more. So we'll still have plenty of time to cover stuff in this class, but I think I'm going to push that back till after the exam. Okay. Related to web stuff, now that I've made a decision to push this back, this doesn't seem quite as important. But when we eventually do have an exam related to web stuff, I want you to know about the HTTP request and response components, the types of requests, and the status codes. All right. So I know Dr. Albrecht has already kind of given a little spiel on the history of the web. That on more of maybe a social side of things, over here you've got Tim Berners-Lee, and over here you have his original computer that was the original server. It says this machine is a server, do not power it down. And what fascinates me is that here he is working in Switzerland. He's a contract physicist. You'd think he'd be worried about splitting atoms, and instead he's got extra time and money to just go and make some software. Like, I don't know how that works. Like, nobody ever has given me a job and says, yeah, just go do something else that you want. But apparently that did happen with him. So he created this, as you know, this two important things. He created HTML, these documents that could be sent around, and he created HTTP Hypertext Transfer Protocol. Let me split apart those two words. So back at that period of time, if you were to open up your help menu in something like Word, then it would show a page that has links in it. And if you click on that link, it would go to another portion of help within Word. So the idea of hypertext was really old. It just means that there's some underlying link that you can click on, and it goes to something else in there. So he saw that happening, and he just kind of had this insight of, hey, what if I add that to this thing called the internet that's out there? So starting with DARPANET, and then it became eventually TCP/IP that replaced that. There's this worldwide network of IP addresses out there, and he's like, what if I wrote this software that bound itself to port 80, and it delivers up these web pages? And I'll just stop talking there. So, all right. So next time we'll pick up. We'll do a review. Probably talk a little bit about firewalls, program some firewalls a little bit. If you need help on the homework, reach out to me. I'm here the rest of the week. The TAs are here. I want to make sure you get any support you need on that, since we will be doing that as part of the exam on Wednesday. There's going to be a review session on Monday by the TAs at 5 p.m., and that will follow whatever we do in here on Monday to review as well. So you got lots of chances to ask questions between now and next Wednesday.